Okay, so this starts part 1 of integration by substitution, also known as U substitution. So basically, when we find an integral, we have to either work from left to right like we normally do, or the only other way we know how to find an integral in Calc 1 is using U substitution, and it's the opposite of a chain rule. So what you want to work on is looking at a function and determining if you can just take the integral or if you have to do a U substitution. So for example, let's say we have the integral of (3x plus 5 to the 7th power dx). Now, in order to take an integral like we know already, we would have to first separate this. So, which means I'd have to FOIL this 7 times, do a whole lot of distributing, combining like terms, and then I could finally work from left to right, because all we know how to do so far is take an integral when it looks like this. Right? We would just work from left to right. We would add and divide. So this would be x squared plus 5x plus c. So the problem is when we have something a little more complicated. So what we're going to do is we're going to look for an inside part. Now, on a chain rule, the inside part, remember when we took a derivative, was typically, I'm going to make a list over here, the part in parentheses. It also could be the part under a radical. And another thing, it could be the part in the denominator. So typically those 3 things we want to look for as the inside part. Another example would be an exponent. So you're going to want to make a list so we can reference this. In the next couple of days, you're going to be practicing finding the inside parts. Okay, so let's take a look at an example here. So let's look at number 1. We're going to go slow through these, and feel free to watch these examples as many times as you need. This is definitely one of the trickier things we do in calculus. Okay, so number 1. Now, I can't really separate this too easily. I could raise this to the 4th power. I could write it 4 times, do a whole lot of FOILing, and then distribute the 2x, and then finally take the integral. But odds are you might make a mistake because that's a lot of things to keep track of. So what we're going to do is find the inside part. Now, if we look at this list over here, do I have one of these things in the problem? And I do. I have a set of parentheses. So what I'm going to do is pick that as my inside part. I'm going to underline it. And it's called U substitution for a reason. We're going to let U equal that part that I underlined. Okay, that's our first step. Once we do that, now we're going to find du, and du stands for the derivative of u. So the derivative of x squared plus 1 is 2x, and I'm going to label it dx, which means I just took the derivative with respect to x. Now, if we're lucky, when we find du, it should equal some other part of the problem, and it does. 2x dx works perfectly. That's du. And then the part that I underlined was u. The only thing left is this little 4 right here. So now what we're going to do is we're going to rewrite our problem. We have the integral. The part that I circled is du. The part that I underlined is u, and then I have a 4. So I'm going to write that as u to the 4th du. So now I've taken a pretty complicated problem and I've simplified it down to just u to the 4th. Now I'm going to finish this up. I'm going to take the integral, and the integral of u to the 4th is pretty easy. We're going to add and divide. That's 1/5 u to the 5th plus c. And we're almost done. The very final step is we're going to plug back in for u. So u we said is equal to x squared plus 1 to the 5th plus c. And that is our final answer. Okay, so let's try number 2. Number 2, I see a radical, so first off, I'm going to rewrite my problem and write that as 1/2 power. Okay, first thing I'm going to do is find the inside part. So typically we look for parentheses first. So I'm going to set u equal to x cubed plus 1. Okay, now I'm going to find du. The derivative of this is 3x squared dx. So I'm going to circle that up in the problem here. That works out perfect. I have a 3x squared dx. So that becomes du. So the only thing left that I didn't circle or underline is this 1/2. So I'm going to rewrite my problem. We have the integral, the part that I underlined, u to the 1/2. The parts that I circled are du. Now I always put du at the end because that's typically where we see it. Now we're going to take the integral, so I'm going to add and divide. So when I add 1 to 1/2, I get 3/2. Divide that, the front 1 by 3/2. It's really multiplying by the reciprocal. And last step, we're going to plug back in for u. So 2/3. U is x cubed plus 1 to the 3/2 plus c. Okay, moving on to number 3. So number 3, I'm going to take a look at this here. I have a set of parentheses, so I'm going to try to set u equal to this. Now, if I think ahead, the derivative of tangent is secant squared, so that's going to work out perfect because it equals another part of the problem. So I'm going to underline that. U equals tangent plus 3. Du, derivative of tangent is secant squared. Derivative of 3 is just 0, dx. So I'm going to do my circling so I don't lose track. I've got secant squared dx is du, and then the part that I underline is my u. So what's left is I have the integral, u du. There's nothing left that I haven't circled or underlined, so u du. Okay, so now I'm going to take the integral. I'm going to add and divide. The integral of u is 1/2 u squared plus c. And I'm going to plug back in for u. So u is tangent of x plus 3 squared plus c. Okay, so let's go to number 4. So I see parentheses here. I'm going to set that equal to u, x squared plus 1. And I'm going to find du. Du is 2x dx. So this one has a little bit of a problem because it doesn't match up perfectly. I have my u, but I have an x dx, but the problem is I need a 2x dx. So there's a way to fix this, and it's kind of weird. What we're going to do is we need the 2, so I'm going to put the 2 in. And that seems weird that you can do that. You really can't do that. So how we're going to fix it is if I put a 2 in on the outside, I'm going to put in a 1/2 because 1/2 times 2 is 1. So really, I didn't change the problem at all. I just put in a 1, but I fixed the problem so that now I have a 2 that I needed. So the only thing that we have extra is that 1/2 on the outside. We're going to bring that down. And what's left, I have the underlined part in the red here. So u to the 4th, and now everything else works out perfectly to be du. Okay, so now I'm ready to take my integral. I'm just going to keep bringing down this 1/2. So the integral of u to the 4th is 1/5 u to the 5th. Plus c. And if you want, you can multiply these two together. That's 1/10. And I have to remember to plug back in for u, so x squared plus 1 to the 5th plus c. Okay, let's try a couple more here. So let's go to number 5. So right away, number 5, I'm going to rewrite this because we have a radical. And I'm going to pick my u. So I'm going to pick the part in parentheses is my u. So u is equal to x to the 3rd plus 1. So I'm going to take my derivative. Du is 3x squared dx. Okay, so the problem with this one again is I'm going to do some circling and underlining here. So I have an x squared dx, but I need a 3x squared dx. So I'm going to fix this. I'm going to put the 3 in. So now it matches perfectly, but I'm going to put a 1/3 on the outside. So now I'm ready to write my answer. 1/3, the integral. This part in green is u to the 1/2, and then everything I underlined in red is du. So u to the 1/2 du. Okay, so I'm going to bring down my 1/3. I'm going to take my integral, so I'm going to add and divide. So if I add 1 to 1/2, I got 3/2, so 2/3 goes out in front. And I'm going to plug back in for u, and I can also multiply these together. So this is 2/9. Plug back in for u, x to the 3rd plus 1 to the 3/2 plus c. Okay, let's move on to number 6. So right away I see parentheses, so I'm going to pick that as my u. Now if you pick the wrong u, like let's say you pick a u and the derivative does not equal anything close to what you already have, you can always go back and pick a different thing as your u. So du, derivative of tangent is secant squared. Derivative of 3 is 0, dx. So it almost works out perfect. Now with this one, I don't have to add anything in. I actually have an extra part here. But the extra part is just a constant. So what we can do, if we have a constant that we don't need in the problem, we can pull it out to the front. And now I'm ready to write my integral. So I'm just going to bring this 2 down. So 2 times the integral, secant of x dx, right? That becomes my du. And then tangent of x plus 3 is my u. So that would be u du. Now I'm going to take my integral. I'm going to bring this 2 down, add and divide. So 1/2 u squared plus c. I can multiply these. That gives me 1, and I'm going to plug back in for u. So tangent of x plus 3 squared plus c. Okay, so again, this lesson can be a little tricky, so feel free to rewatch this video as many times as you need and try to practice these on your own and make sure that you can get these answers. We'll keep practicing them in the next couple of lessons.